To calculate the exact amount of air needed to recharge an aerosol spray can, start by determining the can's required internal pressure and usable gas volume. First, find the manufacturer's specified pressure expressed as pounds per square inch at a reference temperature, and whether that number is at ambient or elevated temperature. Next, measure the empty usable volume inside the can by weighing the can before and after dispensing a known mass of product and converting mass to volume using the product density. If density is unknown, use water equivalent assumptions for rough estimates, but note the increased uncertainty. Use the ideal gas law in its practical form to relate pressure, volume, and temperature, remembering to keep temperature constant during calculations or apply corrections for expected warming from compression. When topping up with compressed air, use an inflator with a calibrated gauge and add air in small increments, letting the can stabilize thermally and then rechecking pressure and spray performance after each increment. For safety, never exceed the pressure rating printed on the can and allow for a safety margin of about 10% below that rating to account for temperature rises during storage or transport. If the can originally used a liquefied propellant rather than air, understand that topping with air changes spray dynamics because liquefied propellants maintain pressure through phase equilibrium whereas air does not, so expect shorter, consistent spray duration and different atomization. Common mistakes include overpressurizing the can, which can cause rupture. Avoid this by always using a gauge and stopping well below the can's maximum rated pressure. Another frequent issue is assuming the can behaves like a rigid vessel with constant internal temperature. Compression heats the gas and raises pressure, so always let the can cool to ambient and remeasure before deciding more air is needed. A third problem is attempting to replace a liquefied propellant with dry air, which alters droplet size and pressure decay. The practical fix is to test spray performance after incremental fills and accept reduced runtime, or use compatible propellant cartridges designed for that product. BigHomeProjects.com helps homeowners find local contractors and compare services related to spray finishing and home projects. We connect contractors with customers and host an active discussion community where we share practical tips and troubleshooting advice.